Welcome to the vast expanse of the universe, where stars shimmer like cosmic jewels and galaxies swirl across the night sky like ethereal whirlpools. From the smallest atoms to the largest clusters of galaxies, everything we see follows the rules of physics, or so we thought. Beyond the visible cosmos lies a profound mystery, something so elusive that we can't see it, touch it, or even directly detect it: dark matter. This mysterious force, hidden from sight, shapes the structure of galaxies and the very fabric of the universe. Today we're diving deep into one of the greatest puzzles of modern astrophysics: dark matter. What is it? Why does it matter? And how close are we to unraveling its secrets? Strap in, because the answers are just as mind-blowing as the mystery itself. Our story begins in the 1930s with a Swiss astrophysicist named Fritz Zwicky. He was studying a cluster of galaxies known as the Coma Cluster when he noticed something odd. The galaxies were rotating far too quickly, so quickly that by all accounts they should have flown apart. The visible mass of the galaxies, the stars, gas, and dust, wasn't enough to produce the gravity required to hold them together. Something was missing, an invisible source of mass. Zwicky proposed that there had to be an unseen substance, something he called dunkel materie, or dark matter, providing the extra gravitational pull. But back then, his idea was largely ignored, dismissed as too strange or speculative. It would take decades for his theory to gain traction. Fast forward to the 1970s. Vera Rubin, an American astronomer, was studying the motion of stars within galaxies. She observed something that seemed to defy the laws of gravity as we knew them. In a galaxy, stars at the edges should orbit more slowly than those near the center, just like the outer planets in our solar system orbit the sun more slowly than the inner ones. But Rubin found that the stars at the edges of galaxies were orbiting just as fast as those near the center. According to Newtonian physics, this was impossible. The only explanation was that there had to be much more mass, something invisible, that was providing extra gravity, keeping the galaxies intact. This was further proof that dark matter must exist. Once scientists accepted that dark matter existed, the next challenge was figuring out what it's made of. Since dark matter doesn't emit, absorb, or reflect light, it can't be detected directly with telescopes. Instead, researchers turned to particle physics. One idea was that dark matter might be made up of exotic particles like WIMPs, weakly interacting massive particles. Physicists built giant underground detectors, shielded from cosmic rays, hoping to catch a rare interaction between a WIMP and an ordinary particle. They also used particle accelerators, like the Large Hadron Collider, to try to recreate conditions similar to those just after the Big Bang, hoping dark matter would reveal itself. So far, the search has been challenging. We've ruled out many possibilities, but every dead end brings us closer to the truth. It's a bit like looking for a ghost. You can't see it, but you know it's there from the way it affects the world around it. Scientists have proposed several ideas about what dark matter could be. WIMPs were once the leading candidate, but there are other intriguing possibilities. Another theory involves axions, ultra-light particles that might behave like waves and permeate the entire universe. Then there's the idea of sterile neutrinos, ghostly particles that barely interact with anything. Some even suggest that dark matter could be linked to an undiscovered force of nature or extra dimensions beyond our own. The truth is, we don't know for certain what dark matter is. It's one of the biggest unsolved puzzles in science. But every experiment, every theory brings us one step closer to understanding this invisible force. Dark matter isn't just some curiosity for scientists. It plays a crucial role in shaping the universe itself. In the early universe, dark matter acted like a cosmic glue, pulling together gas clouds that eventually formed galaxies. Without it, the universe as we know it wouldn't exist. Even today, dark matter shapes the large-scale structure of the universe, influencing how galaxies cluster together and how they evolve over time. If you zoom out far enough, you'll see that the universe has a web-like structure with galaxies connected by invisible threads of dark matter. The search for dark matter is far from over. New experiments and missions are on the horizon. The Lux Zeppelin experiment and Xenonet detector are some of the most sensitive detectors ever built, capable of detecting even the faintest interactions. Meanwhile, the Euclid space mission will map the universe in unprecedented detail, searching for subtle clues about dark matter's presence. And future particle accelerators could unlock new realms of physics, giving us insights we can't yet imagine. Dark matter remains one of the greatest enigmas of our time. It's humbling to realize that 85% of the matter in the universe is hidden from us, existing just out of reach. But that's the beauty of science. Every mystery is an invitation to explore, to learn, and to discover. One day, we may finally unravel the secrets of dark matter. Until then, it stands as a reminder of how much there is still to learn about the universe we call home. Thanks for joining me on this cosmic journey. If you enjoyed this exploration into the unknown, be sure to like, share, and subscribe. There's so much more to discover, and together we can uncover the mysteries of the universe.